Hi, good evening. Today I want to present for the introduction for our computer programming projects. Our group consists of 5 members, Chi Yin Kai, Philip, Simin Long, Ain Amira, and me, Siti Aisha. For the introduction, what is SLAB? Slabs are plate elements forming floors, roofs in buildings and as the deck of bridges which normally carry uniformly distributed loads, acting normal to the plane of the slab. There are two categories of slab, which is one-way slab and two-way slab. For one-way slab, it bends in one direction only and transfers their loads to the two support beams in opposite directions. When a rectangular slab is supported on all the four edges and the Lx over Ly ratio is equal or greater than 2, the slab is considered to be a one-way slab. For a two-way slab, it bends in both directions and transfers their loads and stresses on all four sides. If a rectangular slab is supported on all the four sides and Lx over Ly ratio is less than 2, then it is a two-way slab. The objective of this project is to determine shear force and bending moment for simply supported one-way, simply supported two-way, and continuous one-way slab. Problem statement: overloading a structure will stress the structural materials such as concrete and steel to their maximum limit, and it may result in structural failure and collapse. Thus, this project is to overcome the overload of the slab and determine the suitable load. Program design starts by focus on the calculation by using pseudocode and flowcharts to know the step-by-step description of how to arrive at a solution in the easiest way. That's all for the introduction.
Good day to everyone. My name is Chi Yin Kai. Today I will be presenting about methodology, and my matrix number is F190020. Okay, so the main formula in designation of SLAB is the designation lot. The designation lot can be also called as a design action, and it can be defined as a lot combination and pattern for the unit limit state. Okay, so the designation the designation lot is 1.35 GK plus 1.5 QK. So what is GK? GK is defined as action which are normally constant during the structural progress, and QK is the action that are harder to regulate accurately because of the approximation of overall based on the observation. Yeah, so it is a different thing. Yeah, and as you can see in this table, there are different types of slab. This based on our Python programming one-way slab, continuous one-way slab, and simply two-way slab. So the calculation for the design action is the same, but then the shear force has a different formula because of for the different purposes, and the bending moments is also the same. So if one-way slab is quite simple, it's just V equals to width times length over 2, and the moment is just integrate it, and then width times L square over 8. Yeah, it is a different thing with compared to those continuous one slab, because continuous one slab has more slab. It's more than 2 or equals to 2 or more than 3, so on. That's why it has a more complicated calculation, which is if Fs is the first interior support and Es is near middle of end span, Is at interior support and interior span, Os is at outer support. So it has 4 components that are at the bending moment and same as the shear force. In the simply two-way slab, there are SP and LS. So SP is the short span, which is the moment existed on the Y direction, and LS is the moment existed on the Y-axis of the long span. Yeah, but then the shear force is only BED equals to the N is the design action and times LX over 2. That's all for me. Thank you. Assalamualaikum and salam sejahtera. My name is Chi here. Today I will be present about pseudo chord. So let's get into it. Okay. So this is my pseudo chord. As you can see, it's quite long, so that's why I didn't present in the slide. So let's get into it. Okay. First of all, my program or my team program, I will display that this program is to calculate the shear force and bending moment in these 3 types of SLAB. What is the 3 types of SLAB? So if the user type number 1 or select number 1, it was equals to simply supported one-way SLAB. So the user if select or type number 2, it will equals to continuous one-way SLAB. Okay, as same as number 3 equals to simply supported two-way SLAB. Okay, so how do we know that it is a one-way or two-way? So the user need to determine whether Ly over Lx is more than 2, it will be one-way SLAB, and if Ly over Lx is equal or less than 2, it will be two-way SLAB. Okay, so this calculate R equals to Y over X. Okay, if you type 0, of course it will be display invalid number. So as you can see here, while R is more than 2, so display one-way SLAB is selected. Because why? Because just now we already measured Ly over Lx. If it's more than 2, then it will display one-way SLAB. So the one-way SLAB is a type 1 and type 2, just as I mentioned just now. Okay, the simply one and the simply one way, and then another one is the continuous. Okay, so the user have 2 choices, so they either choose 1 or 2. So let's say if the user choose the first choice, so it will come out as this: display simply one-way SLAB is selected. Okay, so the user will type in the effective span, okay, the thickness. Okay, after the thickness, the user will type on the permanent load. Okay, so of course the S to calculate the GK, the deadlock. Okay, and then to find the live loading. Okay, so after all those things add on, okay, so the user will find the shear force. As you can see, this is the formula, the bending moment. Okay, so it will display the bending moment and shear force. Yeah, so this is the purpose of the program, to find the SLAB of the bending and shear force. So let's say if the user type number 2, so it will display as the continuous one-way SLAB is selected. So but then in this program, okay, there are number of pieces equals to 2, and then number of pieces are more than 2, or it's 3 and 4 and 5 and so on. Because why we put 2 condition in this leaf SLAB 2, which is for the type 2, because it has a different result. The shear force and the bending moment are quite different, so that's why we put a condition here. But the thing is still the same. They need to put the effective short span, and they need to put the effective long span and the thickness and so on to find the GK and QK. It's just that the shear force and the bending moment is quite different. Okay, so you can see here, this is the number of pieces of SLAB is more than or equal 3. Okay, so the result is here. Okay, so there's another thing for the last part is you can see the program type else, and then while R is higher than or equal to 0, and r is lower than or equals to 2. Okay, so what happened is that it will display simply two-way SLAB is selected. Okay, yeah, because this means that, as I just mentioned earlier, if it's less than 2, so it will display as simply two-way SLAB. Okay, so as usual, we need to find the effective length, which is the ls. Okay, for the specifically is effective short span. Okay, so after type in the effective length, we type in the thickness as usual. Okay, and we find the n. Okay, we find the n, which is the GK and QK to add on the design action. So after that, we can proceed to find the bending moment and the shear force. So this, as you can see, this is the shear force formula, and this is the moment formula. Okay, so it will display after you find it. It will display "Thank you for using me." Display "Goodbye." Yeah, that's
good morning. This is our portal. We can see this is start for the programming. So we start. Okay, next we follow with the input. So we print the ly is the length for the y-axis of the SLAB, and the ls is the length of x-axis of the SLAB. Okay, next we follow with the input. We enter the length of y-axis of the SLAB. Or following the decision, we y is smaller than 0, we get the display embedded enter. So we continue with is greater than 0, we get the input enter the length for the x-axis of the SLAB. For the next, we s is smaller than 0, we get the embedded enter. With greater than 0, we next the input. So we print the 1 is the simple support one-way SLAB, and 2 equal to the continuous one-way SLAB, and 3 equal to the similar support two-way SLAB. We next to the continue follow to the input. We select, we will type for the SLAB r equal to the y over s. So next for the decision, we r is greater to this. So the one way is selected. So if one way selected, we continue to the input. Choose 1 or 2. Is we choose the 1 is smaller than 1 and SLAB is larger than 2. It is the embedded display embedded into it. We continue to the is SLAB equal to what they have input the effect span in meter, and the L is larger than 0. We continue to the input thinner for the SLAB. We get a decision is t is smaller than 0 or t is greater than 0. With this is a display embedded into it. So we continue to follow for the input. The plane the self-weight SLAB equal to the thickness for the SLAB s unit weight for the concrete, and self-weight SLAB equal to the s km per meter, and the permanent load including the self-weight. So next to the input permanent loading is next. We p is greater than is smaller than 0. We get the first information that is the t plane embedded entry. With the next is greater than 0, we get the output plane del of gk equal to the permanent load plus cell weight of the left, and del of equal to the gk km per m power for 2. The live block is the internal for exterior for the slab that called QK. Okay, next we continue the input entry of the slide loading. If QK is smaller than 0, this is the for immersion that is depressed embedded into it. So it's greater than 0, we create the design action and is 1.35 GK plus 1.5 QK. We consider 1 m wise equal to design action. Wise equal to the unit is the km per meter. Therefore, it's under the km per meter unit. Next, we plane the cell force. V is the unit is km per meter. And the bending moment is under the km meter per meter. Bending moment is the km meter per meter. Next, we continue the input plane, the printer moment and the cell force and the answer. Next, we print the thank you for using me and goodbye. And the last is the M is a program user manual. Okay. Step 1, we open the Agoda navigator or software to install in the computer. And next, after the install, we open this app and click the lamp on the Jupyter notebook. This here, we click here lamp for the computer. Next, we click the Python 3 on the Python compiler. Next, we type the coding into the compiler. So this picture shows the coding that we type in the compiler. Okay, after finish typing, okay, we run the process. This we run the process. Okay, after run the process, we can show it we input the we can input the type of the column and type process in this first pass. Then input value to calculate the centers for ratio, the ratio for the city along city log, maximum stress and maximum deviation when the program close it. Then this is we must input the value in this. So next, step with the following the below the output and after input value are chosen, so that there be error in the script. The output will display error that the compiler could not run the program. So this is not our program is successful. This is so the after the successful run of the program.
Okay, now this is my terms. First, I want to present what is the radiations. Radiation is manual calculations. So we do the manual calculations and then we need to compare with our codings to make sure the final answer is the correct one. Based on our codings, we have 3 types of the SLAB. So validations, we need to do the 3 calculations. And now let us go into the first part. The first part is the simply supported one way, and how to determine the simply supported one way is based on Ly and Ls value. When Ly over Ls is larger than 2, that means it's a one-way SLAB. So and then we see here is a SLAB software of the SLAB. Okay, when we do the software, we must know that where is the thickness. The thickness from here we take is a 0.12 and 25 is the unit weight of the concrete. And then we need to make sure the permanent load is how much. Permanent load means is a finishes and the fault tiles and so on. Means it did not include, that means it must excluded software of the SLAB. and deadlock is a total deadlock. Deadlock means it's a compound all the permanent lock. This included software and permanent lock. And life lock is the external force. It's something like it's the things which is acting on the slab, like human weight, like kg, because when we work on the slab, they must produce the force, right? And the force we call it is life load. And design action is a standard from the Eurocode. This fixed formula, and J1.35 is a set D Eurocode, and GK is a dialogue at 1.5. Okay, that's ohms. And we consider it's a 1 meter width. 1 meter width means because we all know that the slab, one-way slab, is 2 forces only. These forces are opposite sides, means he just work like horizontal or vertical only. And from here, one-way slab, we know that this force is work to the vertical. And vertical, so we need to multiply with the width to take the kilonewton per meter. And then okay, we calculate the shear force, right? We shear force, V equal to W L over 2, and W is the multiplied by the width, and length is Ly. We take the longer ones, and the W and over 2. Over 2 means the end. These two support, the first support and the end support is the shear force, and bending moment is this formula lah. And then we go to the okay, we know that the answer is correct. Okay, now we go to the continuous one way. Okay, continuous one way, you look at here, we assume the length is Ls, Ly, and thickness, and this continuous one way slab, we just take the number of two pieces of the slab only, and the Ls is a 3.75, and this loading, and the subwave is the same formula with the part 1. And then okay, now here shear force and bending moment, you look at here, the shear force is at first internal support, and near middle of the end the span, and at outer support, because this formula is I take from the reinforced concrete Eurocode book, and they give the formula is something like if we want to calculate the shear force, right? And then we must do 4 steps. One is we need to take the at first internal support, we need to know that the beam here, the force is how much, and the at first support 0.5F is means here first span, first internal support. And then we got the near middle of the end span is 0.65, it means that it's here 0.65, and then the outer support is 0.46F is here, the end of the support here. The near middle of the end support actually means is here. It means it's here. And then the moment is also the same, because they calculate the every points of the shear force and bendings. And here is 0.65F, right? It means it's here. That means it's here. The moment shaped. Okay, this moment is really is ugly, but this can more let you know what is detailed ones. And then we go to the continuous one-way slab is 3 slabs. Why I want to split to the slab span equal to 2 and 3. The number of the slab 2 and 3 is not actually different. Is they left one shear force, one bending moment, one to calculate ones. And you know that this all is the same with the previous one. And then we got the shear force directly. And we know that at span equal to 2 and span equal to 3, the span equal to 3, he have the interior support and interior span. Interior means 3 span, right? 3 span. Okay, the middle ones is the interior support and interior span. That means it's here. Okay, and then go through. Okay, we go to the two-way diary. Okay, the two-way is okay. We can see from here. Okay, two-way is Ly, also the same formula with the previous one, Ly over Ls, but it's much less than 2. Less than 2 is means the two-way slab. And okay, and this formula also the same with the previous. Okay, now we take the moment is 2 short span and long span. Why we need take the long span and short span? Because the force at two-way support here, we have two directions. One is horizontal one is vertical one. That's why we need to calculate the longer and short force, because they have two force. That two force have produced the shear force and bending moment. But the bending moment, but in the shear force, we just calculate the maximum ones. So that we take the NLS over 2. This is the maximum of the shear force in the two-way span. Okay, and this coding is to prove the correct one or not. Okay, we know that. Okay, the answer is the correct totally. That's all. Now I want to pass to my group mate thing.
For discussion, based on the project that has been completed, we had understand the use and importance of programming in our daily life. Each software that had been created were composed by a programming. In this project, we had identified the use of Python in structure solving, which is to calculate shear force and bending moment of 3 types of slab. The steps of calculation has been divided into different parts to ease the running of program and to be user-friendly. Before we started the project, we revised the steps and formula on how to calculate the slab. We spent most of the time in creating the code of calculator. We also had some difficulties to get the coding to running smoothly and always get some errors in the coding. Moreover, we also struggled to program the 3 different types of slab into one program, which is simply supported one-way slab, continuous one-way slab, and simply supported two-way slab. In addition, for the continuous one-way slab, there are 2 conditions that made us struggle more. We did try and error many times to obtain the code that can run smoothly. A few corrections and editing also has been made after the lecturer has examined our coding. However, to make sure the program produced the correct output, each of us made a validation by calculating manual. We then insert the same data into the program so that we can compare between manual calculation and program calculation. It turns out that we got the same results and we are convinced that our program calculation is correct. One of the difficulties in completing this project is communication between group members. Since the COVID-19 pandemic that has been affected in our country, we as students had no other choice than study online. The whole progress of this project was done by online communication using WhatsApp and Google Meet. Fortunately, each member of this project has given cooperation in completing this project. We are still capable to finish all the tasks given by using online platform. This project can be used for calculation that is related to SLAB. This gives benefits to the future generations or workers. They can use it to make their work easier. Perhaps young generation could develop or make some innovation from our project to increase the usability and can be used from different fields. That's all for the discussion.
Hi, my name is Amira binti Omar. My mobile number is CF191084. Today I want to discuss about the conclusion. The conclusion is as a result of conducting the project, we have successfully proposed a series of codes to calculate the overload on the slab and determine the suitable weight. The coding present in the content can be applied fully to the suitable problem of one-way slab and two-way slab. Computer programming also can relate to most of the civil engineering subjects and help us to have a deeper understanding about civil engineering. That's all for me.